Hello biology students. Today I'm going to explain to you how we can calculate the field of view when we are looking through a microscope. So you already learned that the microscopes have 3 or 4 objective lenses, and each of the objective lens has a different magnification. And we always calculate the total magnification by multiplying the magnification of the eyepiece of your microscope, so the ocular lens of the microscope, with the magnification of the objective lenses of the microscope. So when we start with the objective lens, the smallest one, that is the scanning lens. Now here I used a ruler slide, and a ruler slide is just a plain microscope slide with a piece of a ruler glued onto it, and the units are millimeters, respectively centimeters, so 10 millimeters make up 1 centimeter. What we see here is an example of a true ruler slide, but when I did the calculation in lab the other day, I had a little bit of a different results because I used a different microscope. So in my example, my ruler slide, when I measure the ruler slide underneath a microscope and therefore measure the field of view, I see that the field of view is about 4.8 millimeters wide. Between the middle of the one black line towards the middle of the next black line, the distance is 1 millimeter. So in this case, we have a distance of kind of 4 millimeters and then just a little bit. So with a scanning lens, I can easily measure my field of view. Now, then when I move to the low power lens, I can still measure my field of view. And in this case, when I measured my field of view, I had a field of view of about 2 millimeters or 2000 micrometers. Now, then when I switched to the high power lens, I could see that my field of view was less than a millimeter, maybe approximately half a millimeter or 500 micrometers. However, I cannot exactly measure that with this type of ruler slide, but I can calculate the field of view. And this is what we're going to learn today. So let's look at the data that we have. We know that the field of view with a scanning lens is 4.8 millimeters. With a low power lens, it's 2.0 millimeters. And with the high power lens, we know that the field of view is less than a millimeter, but we cannot really measure it. Now, the next thing that we need to know is the total magnification. The total magnification with a scanning lens is 10 times 4, which equals 40. The total magnification with a low power lens is 10 times 10, which equals 100-fold magnification. And with the high power lens, it's 10 times 40, which is a 400-fold magnification. We always multiply the magnification of the objective lens with the magnification of the ocular lens, or in this case, I did it the other way around. Now, if we want to calculate the field of view of the low power lens, we use what we measured with the scanning lens, and the formula for that is that we have to divide the total magnification, so the power of the scanning lens, by the total magnification of the low power lens. Then we multiply the result by the diameter of the scanning lens field of view. So that is 40 divided by 100 times 4.8. When I put this in my calculator, I can see that the result, 40 divided by 100, so the low power the scanning power divided by the high power times the field of view of the scanning lens, and the result is 1.92 millimeters, which is very, very close to the 2 millimeters that we actually measured. Now we can calculate the field of view for the high power lens. So in this case, I'm going to use my measured result for the field of view for the low power lens, and I'm going to divide the total magnification of the low power lens by the total magnification of the high power lens. Then I multiply this result by the diameter that I measured for the low power lens field of view. In this case, these are 2 millimeters. 100 divided by 400, it's 1/4, that's 0.25. 0.25 by 2 equals 0.5. So my field of view for the high power lens is 1/2 of a millimeter or 500 micrometers.